Nuclear power plants are truly amazing feats of engineering and science. They provide clean, reliable electricity to millions of homes and businesses around the world, lighting up our cities and powering our daily lives. But have you ever stopped to wonder what actually makes these powerful plants work? Or what goes on inside their massive structures? The answer lies deep within, in a remarkable substance known as nuclear fuel, a material that holds incredible amounts of energy. Nuclear fuel is like the beating heart of a nuclear reactor, pulsing with the power needed to generate electricity on a massive scale. It's the essential source of energy that makes the entire system come alive, driving turbines and creating the electricity we depend on. Just like a car needs gasoline to run, nuclear power plants need nuclear fuel to keep producing electricity for our homes, schools, and industries. Without this special fuel, these power plants would simply shut down, and we'd lose a vital source of clean, dependable energy. Understanding how nuclear fuel works is important because it helps us appreciate the science and technology behind nuclear power and the role it plays in our modern world. It also allows us to make informed decisions about this powerful and sometimes controversial source of energy for the future. So, let's take a closer look and dive into the fascinating world of nuclear fuel, where science, innovation, and energy all come together. When it comes to nuclear fuel, one name stands out: uranium. This naturally occurring radioactive metal is the most widely used fuel in nuclear power plants worldwide. But why uranium? What makes it so special? Uranium has a unique atomic structure that makes it perfect for nuclear fission. Fission is the process of splitting an atom, which releases tremendous amounts of energy, the energy that powers our homes. Uranium atoms are relatively easy to split, making them ideal for use in nuclear reactors. Another reason uranium is the go-to fuel is its abundance. While not as common as other metals like iron or aluminum, uranium is found in deposits around the world. This availability makes it a reliable and accessible source of energy for many countries. Uranium doesn't just come out of the ground ready to power a nuclear reactor. Its journey from raw mineral to nuclear fuel is a complex and fascinating process that involves several critical steps, each requiring specialized technology and expertise. It all begins with uranium ore, which is carefully extracted from mines located in various parts of the world. These mining operations can be massive undertakings, involving teams of workers and heavy machinery to access the valuable ore deep underground or near the surface. Depending on the geology and location, uranium mines may be either underground or open pit. Open pit mines are used when the uranium deposit is close to the surface, while underground mines are necessary for deeper deposits. Both methods require careful planning to ensure safety and efficiency. After extraction, the uranium ore is transported to a processing facility. Here, it undergoes a series of steps designed to separate and concentrate the uranium, making it suitable for use in nuclear reactors. The first major step is milling. In this stage, the ore is crushed and ground into a fine powder, increasing the surface area and making it easier to extract the uranium. Next, a chemical process is used to separate uranium from the rest of the crushed rock. This results in a concentrated uranium compound known as yellowcake, which is a crucial intermediate product in the fuel cycle. The yellowcake is then transported to an enrichment facility. Here, advanced technology is used to increase the proportion of uranium-235, the isotope necessary for sustaining a nuclear chain reaction in reactors. Finally, the enriched uranium is formed into small pellets, which are assembled into fuel rods. These rods are then ready to be used as the essential fuel that powers nuclear power plants around the world, generating clean and reliable electricity. The enriched uranium is carefully packaged into fuel rods, which are these long metal tubes bundled together to form what we call fuel assemblies. These assemblies are then loaded into the core of a nuclear reactor. Inside the reactor, the uranium atoms in the fuel rods are bombarded with neutrons. This process causes the uranium atoms to split, releasing energy in the form of heat. The heat is then used to generate steam, and that steam drives turbines to produce electricity. The fuel rods can actually stay inside the reactor for several years, providing a constant and reliable source of power. Once the fuel is spent, it's carefully removed and stored until a long-term solution for its disposal is implemented. Nuclear fuel plays a crucial role in our transition to a cleaner, more sustainable energy future. As the world seeks to reduce its reliance on fossil fuels, nuclear energy stands out as a powerful alternative that can provide large amounts of electricity with minimal environmental impact. Unlike fossil fuels, nuclear power plants don't produce greenhouse gases during operation, making them a vital tool in the fight against climate change. This means that nuclear energy can help us meet our energy demands while keeping our air cleaner and our planet healthier for future generations. While uranium is the most common nuclear fuel today, researchers and scientists are actively exploring other options to make nuclear energy even safer and more efficient. These efforts could lead to breakthroughs that further reduce waste and improve sustainability. Plutonium, which is a byproduct of uranium fission, can also be used as fuel in some reactors. By recycling plutonium, we can make better use of our resources and reduce the amount of nuclear waste that needs to be managed. Thorium, another naturally occurring element, is also being researched as a potential fuel source for future generations of nuclear power plants. Thorium-based reactors could offer additional safety benefits and help diversify our energy mix. As we look to the future, nuclear fuel will continue to play a critical role in meeting our growing energy needs while reducing our environmental impact. Advancements in technology and fuel types will help ensure that nuclear energy remains a reliable and clean source of power. By harnessing the power of the atom responsibly, we can pave the way for a cleaner, brighter future for everyone. The choices we make today about our energy sources will shape the world for generations to come.